We've been told for years that the car in our driveway would eventually drive itself. But after a decade of waiting, you still have to keep your hands on the wheel for your morning commute. What we actually got were geo-fenced, corporate-owned robo-taxis that you can only rent by the trip, restricted to specific neighborhoods in a handful of cities. Look at the heavy sensor arrays bolted onto the roof of this Cruise test vehicle. This hardware complexity requires a constant connection to centralized cloud orchestration and daily maintenance at specialized company-owned depots. Because the vehicle relies on that external infrastructure to function, the sheer cost and logistics of maintaining one make private ownership impossible for a standard consumer. Automakers like Tensor are rewriting the architecture to create what is known as AV 3.0. They are building AI-native agentic vehicles designed for personal ownership. In an agentic vehicle, the cognitive intelligence lives entirely within the car. It does not need a constant connection to a remote server or a specialized garage to process its environment. By cutting the tether to the corporate depot, the car transitions from a rental service you book into an embodied AI agent you own. To operate independently, a vehicle must house a localized supercomputer capable of replacing an entire server farm. Modern platforms integrate over 400 individual ARM-based processor cores. These chips manage safety, power redundancy, and the live inputs from over 100 onboard cameras, LiDARs, and radars. This hardware density is necessary because the car generates up to 53 gigabytes of raw sensor data every second. You cannot push that volume to the cloud without severe lag, so it must be instantaneously processed on the vehicle's internal nodes. That local computing power runs a dual-system cognitive architecture. System 1 handles reflexive split-second actions, like braking for a sudden obstacle, using behaviors learned from millions of miles of expert human driving. System 2 serves as the reasoning center. It relies on vision-language-action foundation models to navigate rare, unpredictable edge cases that simple pattern-matching algorithms fail to understand. Pairing massive localized processing with vision-language models allows the vehicle to safely interpret and navigate chaotic streets entirely on its own. Legacy self-driving cars suffer from a black box problem. When the machine suddenly swerves or stops, the passenger has no way of knowing why it made that choice. To build trust, new VLA models use a chain of causation framework. Before taking action, it generates text-based reasoning. It reads the incoming camera feed, explicitly writes, "Stop at the stop line, the light is red," and plots a smooth braking trajectory based on physical constraints. Once you trust the reasoning of the car, the interior can change. Designers are implementing dual-mode cabins, where the steering wheel physically folds away, turning the driver's seat into a spacious mobile lounge. Providing audible, plain text explanations alongside an adaptable interior creates the psychological safety required for a person to let go of the wheel. A privately owned vehicle is an expensive, depreciating piece of hardware that spends 95% of its lifespan sitting parked in a driveway or office lot. An AI-native agent utilizes that idle time. It manages its own upkeep by cleaning its own sensors, finding a station to autonomously charge its battery, and running internal diagnostic checks. Because the car can drive and maintain itself without you, you can deploy it onto public ride-sharing networks while you aren't using it. Companies like Tensor are building direct integrations with platforms like Lyft. Through a simple toggle on your phone, your empty car joins the Lyft network as an available vehicle. While you sit at your desk at work or sleep in your bed, your car navigates the city, picks up passengers, completes daily trips, and generates passive income. Your personal data, locations, and preferences are locked and processed locally on the vehicle's internal hardware, ensuring total privacy even when the car is servicing a public network. Embedding agentic AI into the physical architecture of the car produces an intelligent, embodied economic agent that generates value even while its owner sleeps.